Hello everybody, and welcome to another video on this channel. Today will be the final video in our integral calculus series before I start talking about how to actually evaluate integrals and the different rules involved with them. The first part of this integral calculus mid sub-series was mainly based on defining the integral and a lot of theorems. And this is going to be a little different than that, as it's going to be a mix of the rules and also have some limit or definition of theorems in here. But then we're gonna move on to power rules and cover more examples. But for now, we're going to go over some basic properties of integrals that are very useful when evaluating them. The first thing, the rule that we're going to know is what happens if we have an integral of f of x plus g of x dx. Now, this becomes the integral of f of x dx plus the integral of g of x dx. Now, this rule also applies for negative signs. So if I was doing f of x minus g of x, it's equal to f of x dx minus g of x dx. Now, the reason for this is, let's say instead of plus g of x, we have plus negative of a function. But the negative of a function is also a function. And we can move that minus, and since minus times plus is minus, we can move that minus over there and thus create f of x minus that function of g of x. The third rule we are going to cover is, what if we have a constant, or c multiplied by f of x dx. Now this is going to be equal to c multiplied by the integral of f of x dx, and key that c is a constant. The fourth rule that we're going to cover is what is very specific to definite integrals. Now, definite integrals were covered earlier in our previous videos, so if you don't know what that is, please make sure to go watch that before you watch this video. But what this rule is going to be is it's special to definite integrals. But the rest of these rules can be applied to both indefinite and definite integrals. So, if we have an integral of f of x dx from a to a number c, or let's say d, then this is equal to the integral from a to b of f of x dx plus the integral from b to d of f of x dx. Now, it's a very big theorem, and the reason this works is if we have a graph over here, or just anything, and we have a function like this, if this is a, and this is d, and this is b, if we have the integral from a to d, it just fills this in this entire area. But if we have it from a to b, it fills in the first area, and then b to d fills in the second area. If you add those two areas up, it still equals the original area of the thing, and an integral is just finding the area under the curve. So that's one of the biggest things specific to definite integrals only. Now, also what happens is these rules can stack onto each other. What do I mean by that is, if we have the integral from a to d of f of x plus g of x dx, I can make this the integral from a to b f of x dx, and then plus the other interval, and then plus g of x dx from a to b plus the other interval. So both things work perfectly fine when evaluating an integral. So these are the major properties of an integral in general that you will need to know. So I think that's about it. See you in the next one, and bye-bye.